In this module, we'll be covering uh, the electrical codes and how the national electrical codes are put together, the book, how it's structured, who put it together, and why is it used. So first, we're going to start with the history and the purpose of it. And then we're going to go a little bit deeper into other aspects. Actually, in the class, we will be looking and going through the code book to understand how it's put together and how to find um, different information, standards, and the codes to help us make sure that things are done correctly. So the objective of this section is for us to identify key dates in the history of the National Electrical Code, describe how changes are made in the NEC, and we're going to identify other organizations that produces standards for manufacture and use of electrical components. And there's a lot because electricity can cause harm if it's not used correctly or installed correctly. That these standards and codes becomes law, so everyone um, are required to follow the same procedures. And so it just makes it uniform any place in the United States. Matter of fact, not just the United States, the national or international codes. The first thing, we're looking at the purpose and history. Um, it goes back a very long time. Um, Shortly after um, electricity became used in the public, and found out that it can be used to improve the livelihood of people. Before, matter of fact, safety, because years before electricity, to have outdoor lights, they have to burn something like oil or natural gas to be able to see at nighttime. Of course, they were limited about the light, but the other issue was safety. Many houses burned down because of gas lights or oil in the house. So spilled over a oil lamp, the oil would just burn and burn anything. Because, of course, most of the things that uh, a home or a business was made out of was wood, and it certainly is flammable. So you need to get a copy, which we will have. We will have one in the classroom that we will go through and be able to become familiar with the code book. Now, here's a question. It says, the NEC, why do you think it's necessary to have a standard set of procedures for electrical installation? Next question is, find out who does the electrical inspection in your area. So whatever city you live in, or sometimes it's a small town, it could be the county, but there's will be someone to do inspections. Who determines what will be inspected, when it will be inspected, and who will do the inspection? And that's something to find out. But of course, usually is the municipality, the city usually have a building department, and inside that building department will be code enforcement. And these inspectors will come out to inspect the building for electrical, plumbing, carpentry, or whatever trade to make sure things are following a standard. So the National Electrical Code, what we call the NEC, provides the minimum safe rules and standards. It's, however, it is, they say this is the minimum that you must have, and usually it's pretty high. But a city or state or a county can actually be more stringent if they want to. They can. They can adopt the National Electrical Code. They cannot go less than that because it is the code. A code is Here's the difference between a code and a standard. A code is a legal procedure, a legal document, while a standard is a suggestion. So many standards become codes. So here in the National Electrical Code, it's for the national of the United States, of course. However, there's 50 states in the United States. They can adopt this code book, or they can uh, make it more stringent. So some cities, or some matter of fact, cities or states or counties, they can adopt their own and make it even more stringent. So the National Electrical Code set the standard, and it's up to the city or the municipality to adapt it or to change it to make it more stringent. So again, it the procedures, minimum safety precautions necessary to protect people and property from hazards of electricity. The National Electrical Code is developed by panels of experts who assess the electrical installation hazards and continually revise the standard to maximum safety. And yes, it's ongoing. They just don't take breaks, but every 3 years they will come out with a new edition. Every 3 years. So through those 3 years, there are experts that are working uh, to go through and see if there's any problems in doing surveys and with manufacturers and other building departments looking at if there's any issues during that time period to be able to reassess if there's any changes needed. The first nationally recognized electrical code was published by the National Board of Fire Underwriters, now the American Insurance Association, in 1895. In 1897, the first edition of the NEC was published. In 1962, the National Fire Protection Agency took over publishing the NEC. Now think about that. It's been going around for a very long time, uh, using codes and standards. So during the beginning of electricity for public use, it codes. Here's the reason why, and these dates are really important because um, if you really study electricity and the history of electricity, rather, you'll find out that it was a transition of what type of electricity. Was it going to be DC or was it going to be AC power? And Buffalo, New York was one of the major um, places where they would start to produce electricity by using hydro dams to do it. But the World's Fair, that year, the 1900 World Fair, was a major matter of fact. If you look at the World Fair of Chicago and look how they brought electricity to the city of Chicago, it's really interesting because they lit up where the fair was going to be, lights outdoors. When they built the museums in Chicago, they was lit up, and it was just amazing for people who can go at nighttime and have light and outdoors and indoors. So electricity became a really popular thing back in the day. So again, these dates, 1895. But here's the thing, just think about this. It makes sense if you're going to put electricity that you never had before, and there was a lot of scare tactics during that time when they was trying to make a decision between AC power or DC power. And you can look it up. I'm not going to go into deep, but it was, you could look at Westinghouse and Edison and how they were really behind who wanted to use what type of electricity. But the interesting thing is that because the appearance of electricity not being safe, insurance companies wouldn't insure a building unless they had certain requirements in the building. So that's why the National Board of Fire Underwriters were basically insuring the buildings, and they set codes so they didn't have to pay out money. They're saying this is the bare minimum. Of course, over the years, it have improved greatly compared to over 100 years ago. And so we can look at um, these experts, subject matter experts, to help improve what we have today. Let's look at this picture. And there are some problems, and that's why we have codes. And unfortunately, I can't really blow it up here, but if you look, you can see um, they're just live wire exposed, and it looks like it's freed from a light outlet right there. They tie it into it somehow. You should never see that in the house. This here. It's exposed. You got wires just hanging from, and it's just stripped down. Here's another thing. Right at this point, if it's a construction site and it's just for, it should be some type of cover over that bulb, especially on the construction site. Many times you see pigtails light bulbs like this on construction sites, which is fine, but it will always have a guard around it to protect it, because on a, let's say, a tool or a two by four, something, construction materials hit the bulb. Now you got glass flying. It could get in somebody's eyes, or if it shorts out, the sparks can um, uh, fall on the ground. It could catch a fire. But also, this thing here, should never see this on a job site. This is dangerous. They just got wires punched into outlet to power up these other outlets, and it's going, most likely, if this is the power source coming in, you got all these plugs here, and they're going to overload it. It's going to cause a fire. So again, what's wrong with these pictures? Everything. So now I kind of mentioned some of the things about the revision process, how it starts out, takes 3 years, and go through all these different meetings and drafts and evaluations. Then you go to the public, that others can make comments. When I say public, we talk about experts and not just the homeowners and things. But if they're building inspectors as part of the process, or directors over building departments. So it would be very extensive process before it goes into print. And nice thing about it, they print it every 3 years, and but it's up to the city to determine what version. So they don't have to, a city or a state don't have to adopt the latest one out. They can wait to prove that if those things are required or not, or if there's any issues before they adopt it. So they might be 6, 9 years behind. And it's fine. It's whatever the city decide to use to adopt as their code. But again, no matter what, they will reproduce a new updated book, code book every 3 years. Here's our other organizations and laboratories. And the laboratories are ones that's actually doing the testing. And so they're part of this process. When they find out there's a problem with something, because they test it, they will list it out, and because they actually put the seal of approval on certain things, on supplies or electrical supplies or electrical equipment. And to have that, they have to go through a very extensive thing. So national recognized testing laboratories, like, for example, UL, Underwriters Laboratory. That is, they check more than just electrical things, but that's one of their things they would do. National Recognized Testing Laboratories, National Electrical Manufacturers Association. We call that NEMA. NEMA, if you buy a electrical component that is NEMA rated, you can guarantee you it is high quality, but also probably more expensive too. And so you can buy less quality equipment or supplies, but it makes a difference. The IEC is the International Electrotechnical Commission, and the Institute for electrical and electronic engineers. All these are different organizations that monitors, set policies, standards for the electrical industry. Now, this is basically how the um, terms that we find when it comes to the NEC. There's chapters, there's articles. Articles is not just an article, but it's actually a section in the National Electrical Code. And so when we're looking for different sections, we call them articles. So articles are the main topics of the NEC, beginning with NEC Article 90, the introduction, and ending with the Article 840. Uh, And it's all looking at all the things that they're looking at. It falls in those categories. So if you're going to look at the articles, really talking about the categories of the different sections of topics. The Institute for Electrical and Electronic Engineers, the IEEE, is a professional organization that develops international standards um, impacting electronics, telecommunication, information technology, and power generation products and services. The International Electrotechnical Commission, and again, it's another organization. It's a international organization that develops the let's say the current standards for all electrical and electronic technical components and issues. The National Electrical Manufacturers Association, NEMA, is a association that maintains and improves the quality and reliability of electrical products. And again, like I say, if it's actually rated by NEMA, it's going to be expensive but a high quality piece of equipment. The National Fire Protection Agency, the NFPA, they are the publisher of the NEC. And the National Fire Protection Agency develops codes and standards to minimize the possibility of and effects of fires. Matter of fact, it's not just for electrical, for anything that can cause a fire. So the National Fire Protection Agency, or the NFPA, is an extremely extensive organization that do testing and develop standards and codes for all industries. The nationally recognized testing laboratories, the NRTLs, it's product safety certification laboratories that are responsible for testing and certifying electrical equipment. And again, like the most popular one would be UL. There's others too, like the Canadian Standards, CSA. Um, they are all organizations that make sure that the products that have been manufactured, that all manufacturers are following the same standards and been tested exactly the same way. So once they advertise one thing, everybody going to advertise the same thing because they fall in the same standards. So you don't have to guess at it if this is better or worse, or if they are true with their in their literature about the equipment. It will follow the standards from these organizations if they got their stamp of approval on it. If it doesn't have the stamp of approval, just be leery about it. Things coming out of China, you never know what you will get. Things that actually got the stamp on it. If it come out of China and it got a stamp on it, then you can guarantee you it will work and the way it's designed to. Today, the NEC is ministered by the blank. Is it DOT, which is the Department of Transportation? Is it OSHA, Occupational Safety Health Administration? Is it the NFPA, the National Fire Protection Agency, or a DOE, Department of Energy? Of course, we know that the Fire Protection Agency, the National Fire Protection Agency, is the organization. The internet address to submit input for the National Electrical Code is blank. Now, again, as we it looks pretty similar. Well, maybe not, but if you go in your book and you're reading, it should point out to one exactly. Matter of fact, in the National Protection Agency, they call it Book 70. All their books will have a number with in the National Fire Protection Agency on all the different code books. And each one of these books has a number, but it will lead to that very specific thing. So anything dealing with electrical would be under 70. Other type of products or other type of industries will have a different book to use. So again, if you need to send something out, it would be www.nfpa.org/70. Two organizations working toward the globalization of electronic standards are blank. Is it IEC and IEEE, IEEE and NILA, NELA? It is C, NFPA and OSHA, or is it D, the IEC and NBFU? There's only one that is correct, and is the IEC and IEE.